Hey guys, it's Vince. Today in this video we're going to be discussing the teardown of a Makerbot Method X extruder. Now whether you're using the Method X, all of these extruders are the same. What makes them different is their circuit board. That means that all of their internal components are compatible with one another. Many of you already know this. Makerbot really tries to upsell the fact that they want you to have an extruder for each type of material. We know that's not practical, and therefore that's why I'm offering components that are backwards compatible with all of the methods. And when I say methods, I mean method printers. So what I'm going to do here is I'm going to tear this down real quick. Of course, I've got the tool that comes with the experimental extruder. Now this tool will also usually be prominent when you buy the method. If it isn't, you will require this because this tool is the safest method to release your extruder nozzle. Okay, so you're definitely going to want that. You're also going to want a light version of a Torx screwdriver set. You want a T10 bit, and you're also going to want a T6 bit. Okay, so these are what you're going to want right away. You're also going to want a clean work area. No one usually discusses this. I like working in clean space, keeps my mind clean, lets you really go through and analyze what you're working with your method. The other thing is, we know that this is about a $6,000 printer. On all of my electronics, I use deoxit gold. I have this available in my store. I will show you guys this. I'll put a link in the video description so you can check it out. NASA uses this for a contact enhancer. This is the real deal, guys. It's not cheap, but rest assured, I have seen this stuff do everything from bring dead electronics back to life literally, to literally protecting things for years on end from corrosion and contact problems. This stuff is worth its weight literally in gold. So again, let's start the teardown process. First, you're going to want to remove the extruder nozzle. So again, we're going to go right to our T10 actual bit, and again, a light handle as far as what you're going to be gripping here. Nothing needs to be ridiculously tight. Now, I highly recommend you warming up your extruder first, because if you warm your extruder up, it's going to allow the release of the extruder nozzle much easier. And you just take this tool, and you can see it goes right around the actual nozzle, and then you lift, and it pulls it right out. Okay. Now, we know that we have our PTFE tubing that gets inserted inside the nozzle. You do not want to pull this unit out. A lot of guys do that. I don't recommend doing it, and I'll show you why when we go back into reassembly. The nozzle on these units are all one piece. You can see that. They can be cleaned multiple times. I recommend using a Scotch-Brite in a drill, chalking it up carefully, and then rotating it. I will do a video covering this, but right now we're just tearing down the unit. So we're going to remove our T10 bit, go to our T6 bit. Okay. You can see we've already allocated one of the screw to actually set the nozzle into place. And now you're going to find on the bottom portion of the extruder, you've got these T6 screws. You're going to want to remove them. Again, these are self-tapping, so once again, you want to stay with a light pressure. That's why I said using a screwdriver with, again, we're not using a heavy-duty screwdriver. This is a precision screwdriver for light type electronics. You're also going to have two more T6 screws on the top, right near your conductors for your extruder's circuit board. Remove them. And remove them. We got two more. So we put everything right there. Now what we're going to want to do, the entire top portion will come off. Now, in this case, I've already removed this. Yours may stick because it'll have clips. You want to squeeze the unit and carefully remove it. And that's the idea. The top will separate. Now, you'll notice your top portion has got the LED that will light when the printer is actually printing. That's this clear plastic right here. And then you also have your swivel bearing that actually swivels when your filament is fed through it. This is all in one assembly on the top. Let's lay that aside. Now we can see our circuit board is present. You got two pieces to it, 1 and 2. We're going to take the bottom half and that'll just slide off. Once again, all of these components are available in my store. So you don't have to buy anymore a full extruder if you just need a component, which again makes no sense to me why they would do that, but we'll make it right. Okay, so we've got our circuit board here. And once again, you can see we've got our screws set for the circuit board. You've got these two electronic plugs you're going to be removing. Now, in order to do this, you want to get two probes, at least with sharp tips. And you can see that on each end of this, you're going to come in on each one and just slowly release it. And do the same thing here. You got two clips. You want to press, not too hard. You'll feel it come out, and then we release it. And this again just releases the hot portion of the hot block, and that's how it's controlled. So again, each clip needs to be removed. You can see one says here, and on this side it says thermo. These are your sensors, so we want to be very cautious with these connectors for your hot block. And you can see mine does have deoxit right here. You can see the deoxit there and there. Okay, so what we've got here now is the board is ready to now be disassembled. You can also see the back, and we'll be working on that shortly, but let's stay where we are right now. So what we'll do is put our probes out of the way. Won't need them. And you're going to want the T6 Torx again, and we're going to come in here, and we're just going to carefully unscrew our circuit board. Now, I highly recommend, if you're not familiar with where each type of screw goes, because you can see these are different. These screws are different than what came off of your enclosure casing. What I recommend doing is labeling these, so you'll know these go to the case of the extruder and these go to the circuit board. I've disassembled these so many times that I already know which goes where. You also have got the two screws on top. I'm going to take them off. Boom. And boom. Once again, guys, these are self-tapping, and you want to take your time with this. And now your extruder's board is out. Okay? You can see your triggering mechanism for your filament jam. Everything here is very self-explanatory. If you're going to apply deoxit, you want to apply the deoxit to these terminals right here, everything up here, and of course your plugs for, once again, your thermo and your heater. All set there. So now you can see how we're starting to lay our parts out, and you're all good there. Now, internally, you can see what we've got here. It's a very simple unit internally. Our gearbox is on the other side. You'll see that. We're going to take off right now our filament guide, and that's it right here. Okay, for your filament guide, you're going to want an H2.0, and this is a hex bit. And you can see it locks right in. So again, low torque, locks in, just remove it. All of these parts are simply hand tight. They are not to be molested like you're tightening lug nuts on your car. These are supposed to be very, very snug, and that's it. Hand tight only. And you can see here everything is set. And then there's your bearing. You do not need to remove this bolt. You're all set. Now what we want to do is to get to the internal portion of your filament feed is right here. And we would want to switch back over to our T6 bit. And we're going to go right in here. And you'll notice these screws, once again, are much longer. They're similar to what was holding in your circuit board, but these are longer screws. And I'll show you what I mean. Most videos don't cover these kind of things in detail. I don't believe in that. You can see the length difference. Now, once again, if you're not familiar with what screw goes where, because the heads look very similar, I highly recommend you label what goes where. Once again, I'm familiar with it. I don't need to. And you're all set. So what I do is I put this in a different area. Now we do the same thing. Remove these. And self-tapping screws, once again, I'm going to reiterate the same point. You are to use gentle force when putting them back in. They are not to be stripped by using too much torque. You can see exactly how we're doing this. Now, you can come in here, and you can see there's our pinions. And both of these pinions work on these rods right here. And you can remove one. The other one is attached to one of the plastic gears. It's got a shaft that goes through it. One thing I'm going to tell you right now, if you're going to service your own units, you want to make sure that there's no excess filament in these areas. This is what will cause a lot of havoc with this robot. If you're not familiar with an engineering type robot, this is not a toy. Many of you already know that. If you come in here and you find particulate from filament, clean it out. I recommend doing it probably every 25 hours of use. I always rebuild mine and I never have a problem with it. But again, you want to make sure they look just like this, nice and clean. Compressed air is your best friend. Now you're going to have access also to your, you can see it's up here, it's a plastic clip, and this is your filament jam trigger. We just turn it upside down. Now, there is a difference on the experimental extruder and the 1C extruder. You will find that this piece will be out of steel for those extruders, and on the 2XA and support extruders, these are typically plastic. Okay, ask me why they did that, I have no idea. It's backwards compatible with the experimental component and it's steel. I would replace mine. If you don't have all of your extruders using steel, there's no reason not to. It's cheap enough, and plastic is never going to last as long as steel or stay as true. Once again, your pinion gears, go over these pinion gears. In theory, they should last forever, and certain times you may want to replace them. These are hardened steel, so again, they should, in theory, last forever, and they will naturally last much, much longer if you keep them clean. So make sure they're clean, and we're just going to put that there. We've got our clip, I'm going to put that there. Now you can see there's not much to this. It's pretty much broken down. Now on this side, we're going to begin to release our back portion so we can get to our gearbox. So I'm going to just move our probe out of the way. And once again, we've got the T6 screws. Again, you see those longer length screws for the gearbox. Basically, all your gearbox screws are much longer in length. We should have one on top as well. There's 1, 2, and 3. Once you take them out, the back gearbox plate comes off. You see it right here. Separate that, keep it clean, put your back plate over there. Now your gears are here. Gears go in only one way naturally. You want to make sure, once again, your gears are clean. You can use a little brush. If you see any debris like that, you can clean that very, very easily. You do not want to use any abrasives on these. They are plastic. In theory, these should last virtually forever as long as you're not grinding or naturally getting debris in there. You want to remove your gears. Now this gear is the most difficult to remove because I believe it's pressure fit, and it is attached to the other steel pinion gear that is for filament feed. Under most pretenses, you will not have to remove this. I sell the actual gearbox with this already pre-installed, so you're actually getting a full assembly with the large pinion or large gear here out of plastic, and also the steel pinion gear. Okay, the last portion to be removed would be your hot block if you were going to replace that. You can see we've got our hex screws right here, and you're going to require an H2.5 hex bit to remove these. Once again, it's very simple. Just unscrew, unscrew, and this unit will basically just slide right out. Okay, if I was to pull the screws out, you naturally remove this. So what I'm going to do now is reverse the assembly. Okay, so we're going to go back in, and we're going to go back in. Once again, you see how tight I'm making this? Nothing ridiculous. Good. Good. Again, we don't have to go crazy. Just try to keep them even. Okay. Done. That's perfect. Okay. Same process, guys. If you're replacing your parts, you're just going to go back in, and again, the gray gear will go on the inside peg. You can see right here, and it goes with the larger pinion down. You're just going to fit the mesh. Let's see. Right there. Let the gear mesh match. There you go. Drop right in. You just want to level it using the larger plastic gear. And then the other gear, once again, a clearish gear, you're going to come over here to the larger shaft. You're going to put that in and do the same thing and just drop it in. And that's done. Okay. Now what I recommend doing is putting on your back plate again. Should align perfectly. No gap. Everything looks beautiful. And a real easy way to tell if your alignment's good is try spinning the gears with your finger and just see if they rotate smoothly. If they rotate smoothly, you're golden. Okay, now once again, we need our long screws for this. I'm going to use a T6. Here's our long screws where we separated them. And we just come in. There you go, just like this. And you'll see just how fast, as soon as it makes contact, you're done. Of course, a magnetized tip works really well for this because it holds them. 2. 3. Okay, gearbox is done. For the back, check your gear mesh again with your finger. Make sure everything feels good. Perfect. You also want to make sure naturally, and I did it quick, but I just want to clarify. You want to make sure that before you tighten these screws that this is fully seated. You can see how fully seated it is inside the plastic case. Very easy to do when these screws are out. I naturally didn't remove them fully because you saw the entire process to do it. You can see your brass actual nuts on this side that actually hold it. Now, once again, going with your pinion. I'm going to put our pinion in here, and again, the smaller pinion, you can see there's a thicker pinion and a smaller pinion. You're going to drop it in, and they both go into side by side just like this. You're all set with that. And then what we're going to do is align our pinion shaft guide, and this is going to come in. You're going to go with the long and then the short shaft, and it should just drop right on in. Let's see, right like that. You can see exactly how it fully seats right up to the edge of the extruder's block. Okay? Now what we're going to do, once again, we take our long screws, T6, and just right in. Now I recommend a diagonal pattern when you're actually inserting these. That's best practice because again we're trying to exert the same amount of force evenly on this, and once again just very easy. Many guys out there are probably thinking, should I lubricate those gears? You should not lubricate those gears. You want it to be clean and dry. Nothing with direct liquid lubrication. If you wanted to do any lubrication, which I still don't recommend, you would use a graphite lubricant. That's best practice. Done. Now that's done. You see how fast this is going together. Now what we're going to do, this right here puts our filament guide right there. That's the screw for it. So we're going to get our filament guide back with the bearing. Here it is. And we're just going to come over here, move our leads out of the way, drop it in, grab our screw. And this is kind of a funny looking screw. It's the hex screw. You can see it right there. We're going to switch our bit. Come over to the correct size, which is H2. You'll see that right here. Lock in. Insert it in my bit driver. And I just hold this up until I can get the screw started. And it'll go right in. Done. Okay. Very, very simple. And again, this is for the opposite side of where the gears are. So you can see now your filament's coming in. Now, this is a very critical portion. You want to make sure you don't assemble and put back your circuit boards without inserting first your filament jam trigger. You want it to go in with the triangular portion towards the gearbox. So it just slips right in. There you go. Now we grab our electronic circuit board portion. So you guys see how fast these are to really work on. And if you get good at it, it's really quick. Once again, keep your tools organized, switch your end bit. And you're going to want to go over to a T6. And we got the smaller versions of the screws right there, and they are the round head, and these are dedicated to your circuit board. Coming again, up to it. Very light on these. These are doing nothing but holding the circuit board. There's no pressure required. Once they seat, that's it. Done. Go to the top. You'll see two pegs that will lock in, and there they are. 1 and 2. Let those pegs lock in. And now what we're going to do is come in here with the same screws and just mimic what we just did. We go on top. I'm trying to give you a camera angle. Done. Done. One, two. Right there. Perfect. And we just plug our plugs in. Once again, these I like to keep the thermo plug, which you'll see is insulated from heat, and that's that sheath going over here. I like to keep this plug first. Line it up. It takes a little practice, but you can get it if you just take your time. Got it? Not like I had it. Right in. And now we're going to do the same thing here. And again, this is the, you'll notice these wires are much stiffer. So just take your time and align everything perfectly, and you will have magic. There you go. That's in, and you'll see how it kind of like floats. The leads just have to float. You don't have to have perfection. What you're essentially trying to do, you can see if you look carefully, there's a guide right here. And that guide is for when you insert the bottom portion of the extruder, it's going to allow the leads to clear. So you want to make sure all of this is carefully done. We do that, bring it over. You can stretch this, but I recommend just having enough clearance, and you can see how I have this nice and neat now where it bends. Everything is neat. Soft bends, of course, nothing harsh. Now we come over here. We're going to insert the bottom portion of our extruder. It cleared perfectly. Everything is right there. And now our top portion. And again, you will have a top clip. It'll actually snap in. Just use light force, and it'll snap right in. And you're good there. Now, we will insert our T6 screws. You can see the taper on them. And that's so that they end up flush when you actually put them inside the case housings. Same size length, once again tapered. Go. Bottom. The whole key with this is being gentle. You're much better off being gentle than being abrupt, because worst case scenario is you're just taking your time to do it, and you may have a little trouble, but you're not going to damage anything. Okay guys, the final portion of this video is installing the actual extruder nozzle. Now I already said in the beginning of the video, you do not want to remove your PTFE tubing, and the reason you don't is getting it in the exact same spot after filament has been heated in it on a new actual extruder nozzle, not a big deal, but if it's already had filament in it, you're not going to be able to usually insert this easily back here to give the proper spacing. You can see how these feather out, and they feather out just like this when they're installed in order to give proper spacing in the extruder. So leave this inserted, don't pull on it, and take these feathers, because they kind of remind me of a feather on like an arrow. And what you're going to do, and you got that little hole there, you're going to insert these inside there. And I know guys are saying this is pretty difficult to do. It's really not. You just want to take your time. And I take a probe, and I just come in here like this, and I'm just going to hold it and rotate slowly. And what I'm trying to do is feather them to go right inside the hole as I slowly rotate it. It doesn't matter which direction, you just take your time and it will come. You'll feel it, it'll go in. Oop, I think I got it now. You see how I'm doing it. I'm just kind of, there it goes. And now it'll drop in, watch. As it drops in, careful, you can see your feathers are all perfect. And they're coming right here. So you want to fold them down. We're going to do this carefully. I'm just going to rotate, fold down, and just rotate again. You got two more. And what you want to do is just keep folding them down. Right there. Fold down. And now come up, and you can see they're all perfect. You want them all out. You can see that. And as you go to push in, that'll give you your spacing, and just press. Make sure your extruder nozzle is properly bottomed. Now I have rubber padding on my desk. I also have a silicone soldering mat. I would use that, and I grab the actual hot end, and then I just press. And I don't press too hard, just the right amount of pressure, just to make sure you're seated. Once that's done, you're ready to insert your set screw. And again, it all depends on what extruder you're working with as far as the set screw to hold in your extruder nozzle. On the 1C, you can see that you were using the T10 set screw. This is also applicable on the Experimental Extruder Gen 2. On a 2XA support, you are using a hex set screw, which is once again, let's see, a 1.5, I believe. Yep. So these are things to just consider. And that's about the only differences in the extruders right now, is the set screw that holds the nozzles in. I've had questions of, can you exchange nozzles? Yes, you can. I mean, the nozzles are fully exchangeable. Whether or not Makerbot wants to make that clear, you can do that yourself and test. I've done both, and they work fine. So the big thing here that makes this printer, I found usable in terms of consistency, in terms of reliability, by far, hands down, is the slicer. I recommend Simplify 3D. Many of you don't know that it's compatible with the Makerbot Method series. It is. And I'm telling you right now, best investment I ever did. You get a 10-day trial period with the software to see if it works. Test it. If you like it, you own it. If not, you go get your money back. And that's unheard of in this industry. So if you're serious about getting the Method to be productive, it's a fantastic printer once you actually have a good slicer with ooze shield settings and settings that actually make the print overall much more user-friendly as far as your settings. Makerbot dropped the ball, unfortunately, on the cloud software that they included. That's what made the printer so difficult for most end users. Other than that, changing parts now has become a joke. You guys have seen it all done. And best of all, you don't have to buy a mass amount of extruders anymore. As a matter of fact, I'm going to make a recommendation right now. The only extruders you really need is the experimental version, because it prints any filament on the market, and a support extruder. If you're going to allocate, and they want you to allocate different extruders for different types of filament you're using, why would you allocate different extruders when you can just change the nozzle out and allocate an extruder nozzle to a specific filament? It's a lot cheaper, it does the same thing, and you don't need to spend a ridiculous amount of money on the extruders. Do yourself a favor, sell the extruders you're not using, buy the Experimental Labs extruder, and keep a support extruder for what you require, and change the nozzles between the two, and you're pretty much golden. So I hope the video has been helpful. Take care.